What's going on, folks? It's Mike here, and welcome back to the SDL2 series in C++. In this lesson, we're going to be working with multiple colliders. So I've put back our picture of Kong here so you can see the idea where we can have multiple box colliders for different pieces of this sprite image. So if you want, go ahead and review the previous video if you haven't seen that to see how we handle colliders and implement it from scratch. Otherwise, we'll continue on with this series, have the ability for each of our game entities to have multiple colliders to get more precise collision. As always, if you've been enjoying this series, like and subscribe. Let's go ahead and jump into it. All right, folks, so here we are, and we've got our code here. And the first thing that I need to do from our previous program is, of course, add in Kong instead of the test image that we've been using. And I've already included this if you want the source code, which is available. And let me go ahead and just do a recompile and show you where we're at here. So what I'm going to go ahead and do is run the program, and we'll see our Kong character moving around here. And again, this image, we can detect collision if we click. Now, of course, the collision isn't very accurate at this point. It's just detecting if anywhere in one of these pink rectangles that the actual object is colliding, where we want much more precise collision with the actual Kong character. So what this can require is us either specifying more specific hit points, meaning multiple colliders, and then tightening those bounding boxes up. So without further ado, let's go ahead first start by just adding the ability to make things transparent, and then we'll go ahead and modify our code so that we can have multiple colliders. So I'm going to go ahead and stop this. And what I'm going to go ahead and do is go into our game entity class here. So let me go ahead and just review briefly for folks who might be hopping in here, the game entity class. And we'll go ahead and see that that's on the left side here. And what I'm going to want to do here is basically set the ability for us to have a transparent texture. We might not want all of that on all of our objects. So in a previous lesson, which I'll link in the description below, I do talk about how to set the color key. So I'm just going to go ahead and bring in this documentation just so you can see that as a reminder here. So for a particular surface that we're drawing, we can set the actual pixels that will not be shown. And that is the actual key here that we have here. So let's go ahead and set this up so that our game entities can render properly this Kong image. I'm going to sort of make a decision here about how I want to do this. Again, this is probably part of the actual textured rectangle, not the game entity themselves. So let's go ahead and actually modify the textured rectangle. And we're going to go ahead here and just set some parameters for the transparency. So let's go ahead and just I'll create a function here called set color key. And we need the 3 colors that we're going to have here. Let's assume just red, green, and blue for now. And blue. And then let's go ahead and in my textured rectangle here, set up that actual key here. So I'll go into the implementation. And let's go ahead and right under height here, I will set up the color key here. This is part of our textured rectangle class. Set color key and the red, green, and the blue value here. And I've got to make a little bit of a decision about how I want to set the different keys because every object could technically have its own key. So I could set this per frame that I'm rendering or per object. For now, I am going to do this per object. It might be a little bit too intense, but I think it'll make things organizationally just a little bit easier if we have multiple objects with different keys. In general, I'd recommend for a game you have the same sort of key. It'll make life easier for your artists, but let's just go ahead and set it up here. So color key, I could set this up actually as a single integer, and that might be fine. But for now, I'm just going to do this with one variable at a time. So the red key, green, and the blue key. Green key, and the blue key. In fact, why don't I just be ultra specific here and specify them as blue color key, green color key, and the red color key. And again, you can optimize this and just have different values or whatever you want. That's sort of up to you. Now, by default, we could set a color key for all of our textured rectangles. I am actually going to do that because I think it'll make life a little bit easier to have default values. For one, you never know what the value is going to be, meaning initialized in memory here. And this is a pretty typical color key here. So I'm going to go ahead and just set it as such. And then we'll actually use the SDL function here, which is, again, if I bring that up on the screen here, set color key. So let me go ahead and widen this back up so that you can see the following function. Again, SDL set color key. It takes the surface that we are rendering on. So this actually introduces something interesting here because, well, let me look at our textured rectangle. I have our texture here, I have our rectangle, but where is our actual surface? And if you recall where our actual surface is, that is actually in, well, a class that we haven't touched for a while, but the resource manager. And that's actually where we load up our surfaces here. So we have to make a little bit of a decision here to figure out where do we actually want to store a surface? Would we want to store perhaps a reference to it, or perhaps as part of our resource manager, is that something that we want to handle when these surfaces are loaded? So again, we just have to think a little bit about this and how this is going to be handled here. Recalling that our surface that is retrieved here from our texture rectangle here, this is the one opportunity where we have our actual surface and we would need to set the color key. So actually what I'm going to do here is I can provide I guess another constructor might be okay, since this is usually one thing that we have set. So I'll change my mind here a little bit. And again, it's always just about figuring out what makes sort of logical sense to set up. And I think it would make sense when we're loading an actual surface to just set the color key. Maybe we would want to get the color key at a later date. And actually that cleans up one of our worries earlier with, just, I'm a little bit uncomfortable actually with creating all the keys here with the rectangle. That's a little bit too much memory for not a lot of work here. So I think it's actually better to just create another constructor here. And then, well, actually, again, I'll take that back because we're going to need to, again, support the ability to have these different color keys. But I do like the idea of having another constructor here. And then with the default color key set here, which we have, and then maybe I could pass in 3 different parameters here. Now this sort of begs the question, should I have some sort of helper function here to initialize or make sure that all of our objects, when they're constructed, are initialized in a sort of uniform manner, especially if I'm going to have multiple constructors. And I think I will do that here by constructing this particular object with 3 different color keys here. Red color key, green color key, and the blue color key. And then I'll go ahead and give myself an initialization function, which again, I might go back on my word on this, so don't take it for salt, but sometimes you can have a little initialize function that is called inside of your structure, just to make sure that everything is initialized in sort of a routine manner here, meaning these variables here. It can introduce a little bit of complexity here. So again, I might go back and forth about that a little bit here. Oops, this is just called init here. And basically, I just want to set all the default values here in this function. And maybe there's even a better name for it, just so it's clear. Init default. something like that would be okay. And this is something that we also do want to think about in the sense of, should this be public, or is this something that should only be used in the actual constructors? For now, I am going to leave this as a public member variable. I think it's okay. But we might want to make this private if it's only meant to be used in the constructors and not called. But I think it actually could be sort of a useful function to have to sort of reset things in our actual game, or allow people using our APIs to figure out what the defaults are when they reset things. So that would be the justification for that. Again, you might make a different design decision, and that's the fun part of software engineering. So anyway, what I'm going to go ahead and do here is create our surface here, just as we were previously doing. And instead here, we're going to have the 3 parameters. So let me go ahead to the end of this line here and add in our red color key, green color key, and our blue color key here. And similarly, with each of our constructors, I'll init the defaults. Here I will also initialize the defaults, but after this function call, I will set the color keys here. So M red color key equals the red color key. Okay, and likewise here. It's going to be the green, this will be the blue, and so on. And again, I just want the ability to support multiple different color keys. I think that's something that's going to be universally useful rather than just specifying one color always. Okay, so I've now added that feature in, and as we add in features, we should do a build and see if I've made any mistakes, whether silly typos or not. And it looks like I have a couple here. So I have no default type. That's this first error here because it's not a constructor. So let's go ahead and try to rebuild, just fixing one thing at a time from the top, and good to go. Okay, so now that I have that, what I actually want to do now is in my textured rectangle, what I'm going to do is, again, I will get rid of the set color key. I'll only give folks one opportunity to actually implement that particular function. But as part of the rendering portion, what I want to do is actually set the color key here. So what I'm going to do is SDL set color key. Let's go ahead. Well, actually, let me think about what I'm doing here, actually. I don't need to do this in the render because, again, SDL is going to try to be efficient. And I really just need to do this in my constructor here before I create the actual texture here. So once I've loaded this surface, again, this is the surface that I'm getting back from either the resource manager or wherever, if it already exists. This is where I now want to set the color key here. So set the color key from the retrieve surface, whether, again, that's a new surface that's been allocated or retrieving one that's previously been allocated. And then SDL, we use map RGB or whatever the surface was, and get its format, and then whatever the red color key is, the green color key, and the blue color key. Okay, so there we are here. Now again, we might want to retrieve the surface and reset the particular pixels to different color key if we want to be able to manipulate that texture at a later date, but for now, this is fine here. So ability to set the color key for our textured surface. Okay, so again, let me go ahead and see if I've made any tiny mistakes here in this particular function here. Looks like I have missed one parentheses at the end. Let me go ahead and fix that. Oops. Here we are. Yep. And do another rebuild here. And looks like I'm actually maybe missing one of the parameters here. So again, if I enable this as true for the actual color key versus false here, and this is actually a nice thing to pay attention to. So this is SDL true here. Let me go ahead and rebuild this, because we'll probably want the default then, if they're not using this constructor, to be false for the actual color key here. So I do want to now disable this functionality here for our particular surface. So let's just go ahead and do false here. Okay, so there we are. Hopefully this should compile. Actually, there's no parameters there, so let me fix this here for whatever the format is. And I can just use the defaults here. Let's just go ahead and do that. They're specified in hex in the examples that I've used, so and in the SDL documentation, so that's why I'm specifying these in hex here. Okay, so we've got a build here, so that's good. And let's go ahead and in our main now make use of one of these textured rectangles for one of our objects. So what I'm going to go ahead and do is go into the main and see where I'm creating the actual objects here. So I've got the textured rectangles, and let's go ahead and see here. This is where I am creating each of them. Okay, so how do I get to this actual surface and make sure that I'm constructing it with a particular constructor that I would like here? And then this is where things start to get really interesting with our sort of design decisions. Because again, if I look at our sort of API here, we just have the ability to create this game entity with our render and then the image that we're passing in. Now I could start adding other flags here, you know, for which constructor to use or to pass in the red, green, and blue positions. But again, things start to get a little bit messy here. So let me go ahead into my game entity here, just so you can see the API. And again, what we really want here is not to always specify the sprite path here. Maybe we just want to always specify the render, but then have an actual add component where we actually add the textured rectangle. And eventually what we're getting to is we're going to want to do that for our colliders, so that we can add multiple colliders here as well. So I'm going to sort of change things around a little bit. And it's kind of fun to think about this evolution here, or hopefully it's fun, so you can see the actual, you know, how the progression is. So you can see there's already, you know, some problems when we have all these sort of different constructors here. Why not just have maybe one where we have to specify the renderer here? I actually like that. And we'll get rid of this string path here and instead make that part of adding the sprite component. Okay, that way I don't have to, you know, forget to initialize any of these things or whatever here. So what I'm going to do is just sort of prototype here. And actually, I'll write in our interface here the ability to start adding components. Okay, so what I'll go ahead and do is add textured rectangle component, and this will take in a textured rectangle. Now we have to make a little decision here. Do we pass in a pointer? Does it become a copy? How does that sort of work? For now, I'm going to pass in a copy that will get allocated here. So let me just do this as such, and we'll paste this in here. Okay, so this is going to be a void game entity. And now we will create a copy of this rectangle for this entity. Now, as I am thinking about this, maybe the easiest thing to do actually for this particular video is going to be to just have two different ways to add textured rectangle components. I don't exactly like that right now, but I actually just want to get something up and running here. So I'm going to actually change this around so that we just have a string and a sprite path for one of them, and a string to the sprite path, and then the color keys here. Red, green, red color key, green color key, and the blue color key here. Actually, I'm happy enough to live with this here. We have the render, the sprite path will be passed in. So let's go ahead and just do the string here and the sprite path. And likewise, let me go ahead and get rid of this. And we can get rid of this constructor. So our objects are going to be constructed a little bit differently here. Our default constructor is just going to give us a game entity that is 100% empty, which I actually like that much better. And then we can sort of build up these objects over time here. Okay, so this is going to be one of our ways to create a new textured rectangle here. Then we'll have our second way that includes the different color keys. Let me go ahead and get these in. Red color key, green color key, and the blue color key here. Okay. And now our textured rectangle. So again, just to do a quick split here to show well, what exactly it was in our API we had. We still need the renderer, the file path, and then each of the color keys here. And those will be passed in as such. Red color key, green color key, and the blue color key. Being very careful to get those in the right order here. So let me go ahead and do a build here just to make sure that things are working. Oops, looks like I added in one extra int call here. That's going to give us a cascade of errors. So let's go ahead and just handle these one at a time. And now it looks like we can deal with our actual main here. So get back into the main. I'm going to leave our interface up here. And, well, where we construct our objects, again, we are going to actually have to do a few more steps here. Again, we don't have this here. We're going to have to actually create some textures here. And this is actually kind of nice in the sense that we might be reusing or able to share some of the textures now between the actual components. Eventually we'll be able to abstract that, and instead of just creating a new one every time that we add this textured rectangle, I could just pass in a pointer, for instance, to something that already exists in some other resource manager. So there is some value longer term in what we're doing here. We'll have to control the complexity a little bit in this series because it's a little bit of an introduction, and now we're getting into architecture a bit, but I hope that's still interesting for folks to be thinking about. So I'm just going to create one textured rectangle. For instance, let me actually just follow through and use our API here. Okay, so it's all going through the game entity right now, which is fine. So let's add our textured rectangle component, and let's just make sure that this works first, and then we'll try one with the color key. So we'll do the same thing here, this time with object 2. And again, our constructor has greatly simplified here, which I do like that. And then we'll sort of build things up slowly with little components here. Okay, but 2 steps here to build our entity. And oops, it looks like I actually do want to keep that renderer here. I believe I deleted it, but then we should be in good position here. So let me go ahead and open up game entity here. And keep that single constructor here. What did we have before? We just had the SDL render, and that's all we had here. And set our mRender to the actual renderer that we're passing in, which is part of our app here. Okay, so let's go ahead and rebuild that. And make sure that we have a associated constructor that takes in the SDL renderer. All right, one last dare here. Then I think we'll be in business and getting Kong to render, which is good news for all of us. And let's go ahead and just give that a run just to see what happens. And here we can see Kong rendering. Oops, but a little segmentation fault. And let's see what we might be missing here. Let's make sure that we have all of our components here. And we have to make sure that we, so by default, our collider I have made null. And this is where actually we can start doing the same essential thing here where we add our collider component and make that a separate thing here. So since we haven't added that, let's go ahead and look at our collider component. And let's go ahead and see what is going on here. Actually, this is a good use for GDB, just because I like to show you the different errors that could be happening here. So we're running our program in GDB, I like using the text interface here. And I'll go ahead and run here. And if I bring the window in, as soon as I click here, we'll see that we get some segmentation fault, and this is happening in the is colliding code here. Again, because our collider that we're testing against doesn't exist. We've set these to null here. So that's what I'm going to go ahead and fix. I sort of just had a sense that was the case, but that confirms it. So let's go ahead and look at our collider 2D. And let's go ahead and see here. So we do want to check to make sure that our collider, so if m collider rectangle is not a null pointer, that is one thing that we want to check here. Let's make sure that that is okay. Actually, let me look at the interface here in collider 2D. Since we just made this a regular rectangle, that makes things a little bit tough here. So we might want to actually change this to a pointer so that we're actually allocating and creating this. Then I can do a null check. And then I can also sort of lazily initialize this in case I actually don't use this rectangle. So that's a little bit of an optimization here. Let's just go ahead and fix that. Here, that's going to cause a few fixes here. So these are all going to be arrows now, and we'll actually have to allocate this. So m collider rectangle equals new SDL rectangle. All right. And we might have to change, so this is not the address of, but the actual pointer. And let's go ahead and take care of this. All of these arrows. There's probably a faster way to refactor this in Vim. Maybe folks will know. Okay, so let's see here. Still returning true false here. Passing in the collider by reference, that seems fine. And then the collider that we're retrieving, just dot, that seems okay. So let's go ahead and see what we get here. All right. And let's see, in our collider 2D, where we're returning here this reference, since we want the actual object here, we need to dereference it. So that is one fix. And let's see, conversion from SDL rect to construct, okay. Oh, so we are actually, yes, getting the rectangle component of our collider. Last fix there. Let's see, a non-pointer type here, because this is a actual collider now. And we could just retrieve the actual pointer there, so we're okay. Actually, Again, I messed that up. This is just grabbing the field, which is a pointer type here. Okay, so now we are working there. And let's just go ahead and now we can do some checks here. So if temp equals null pointer, we return SDL false. And we would also want to do a check here if, let's go ahead and just say our M collider rectangle for some reason is equal to null pointer. We would return SDL false. And those are the Boolean types there. So now I believe if I run this, our collision should, it's not going to work yet because we haven't added a collider component, but let's see if we're able to avoid some seg faults. If I click, nope, still a segmentation fault. So let's run through in GDB again and see what happened. And I'll go ahead and run this, bring in my window here. I'm going to click, and let's see where we got our segmentation fault here. Checking for the null pointer, because it looks like, well, let me go ahead and get rid of this. Let's just make sure that we are always allocating our rectangle here. And we are doing so in our constructor. That looks good. All right, and then it is just the object inside of our actual game entity that looks like we need to fix here. The way it's a little bit silly because we do have this null check here, but it's still giving us the illegal access here. So let's go ahead and add a collider component to our actual game entity here and sort of fix up our interface so we can take care of this problem here. So just like we added the rectangle component, I'm going to follow suit here. I'll have sort of our add component, retrieve textured rectangle. Maybe just call these retrieve components. There we are. And let's go ahead and void add collider 2D. And for our parameters, let me do just a quick window split here so I can see, again, the collider components. There's nothing here, no defaults or anything for the X and Y position. Again, those were set explicitly by setting by setter functions. So I'm just going to follow suit there. And let's go ahead and let me go ahead and move these in the appropriate position here under render. So I'll have my collider functions here. And this is part of the game entity. And add the 2D collider here. Oops, looks like I moved something. Let me just be a little bit careful here. Okay, should be okay. Okay, let's go ahead and add our collider. Add collider 2D. And we're just going to create a new collider. And by default, that's a collider 2D here. So let me make sure that it builds and runs. Of course, we'll still have our seg fault. So now that we have our new function here, I'll leave the interface open so that we can see what's going on. But let's go ahead and open up our main. And now for object 1, we'll have the textured component here, object 1, and add a collider 2D. And for object 2, we'll also add the collider 2D here. Now let's go ahead and take a look, see if this works, and see if we need to do any more debugging. All right, so let's give it a run. And I'll just run it as need be, and we've got our collision here. Okay, so now let's go ahead and do what we were originally trying to do, and let's try to add, when we add our textured component here, let's actually specify the color keys. So I'm going to go ahead and do that like such, and let me make sure I'm actually matching the color here. So this is fully red, nothing in the green component, and a bunch in the blue. So this is how I'll know the right constructors are being called, and the right textures being rendered by doing this for one object and not the other. And then we can actually see this in action here. Now this is pretty cool because we can see the actual bounding box now of the object, and we can see that it's actually much larger, which is pretty neat. And since we're using just the SDL draw rect function, the color key doesn't apply to this object. So again, we have that sort of debugging view where we can see the colliders. Okay, so this video has been going on for a while, but I still want to add the last sort of component, and that is adding multiple colliders to our actual object here. So we can actually tighten things up and have multiple collision boxes as part of our object. So let me go ahead and shut this down. And in order to do this, let's go ahead and observe some of the logic in our game entity class here. And instead of just having one collider here, well, essentially we're going to need multiple colliders. So what I'm going to go ahead and do here then is give us a data structure that's convenient to add to. And that is the vector. A sufficient data structure, likely if you're watching this series, you're familiar with it, but basically it's a dynamic array here. So instead of having just one collider here, I'm going to have a vector of a bunch of colliders. So I'm going to rename this variable to colliders, plural, to sort of give the intent that there's going to be multiple here. So that's just a small change, might cause some compilation errors, that's okay. And we are going to need to make a few little changes in our actual program. So the first, while I'm thinking about it, is in our destructor, is basically I'm going to need to loop through this actual collection here. So what I'm going to want to do here, and I'm just going to write this as a old school style loop here, is say, okay, for all of our colliders, basically delete them here. So that way we won't have any memory leak. Colliders at I, and that takes care of that here. And since this is a vector, this is actually going to be handled by the standard library as far as allocating it. So I don't need to actually make this null or anything of that nature here. Okay. Our update is okay here. Other than the fact that we will have to think a little bit about how to set these collider positions. Actually, now it's not so easy in the sense that we're going to have to update our colliders in either having a absolute point and sort of offsetting them somewhere when they're created, or just setting the absolute path every single frame. For now, I'm going to get rid of this bit here. Actually, well, let's get rid of all of this update code because we don't really need it anymore. But I'm just going to do that manually for now because I do want to think a little bit more about the API and having sort of relatively positioned colliders relative to the actual sprite and absolute positions. Okay, with that said, when we render our colliders, we're going to need this same style loop here. While I is less than colliders.size I++. And then we'll actually want to draw each of those. And we won't worry about if they're null or not, because, well, actually, we will want to actually do that test here for each collider. It is possible some of these colliders could fall in here and be null in our collection. So we do have to be a little bit careful here. So let's just go ahead and let's just be super conservative here. colliders. Okay, and I want to do that same thing above here. And I got an S. Let's go ahead and see. It's safe to delete something that's already null, so we should be okay there. Okay, and now when I add my collider here, I essentially want to push this back into our collection. So M colliders, push back the new collider here. Okay, and that'll be the idea here. Now we'll have to pass in an index now in our actual code here, where we're getting a collider. So that the collider that we're actually returning is the one that lives in our collection here. At I, or rather at the index. There we are. Actually, there's a much better data type for working with these things, size t, just to ensure that on different architectures, we have a unsigned integer. Okay, now I think this is looking pretty good here. And let's see, we are going to have a bunch of changes in our main here to make as well here. So let's go ahead and see how we are handling this particular code here. So let's go ahead and see. Well, we can check against one particular collider for now. Let's assume every object just has the one collider when we add it. That's our code here. So that should fix that portion. And let's go ahead and see. We're going to have to now also position each of our objects colliders. So this means we'll have to do object one. We'll have to actually get the particular collider. So let's do get collider 2D, add a particular index, and then we'll have to get the actual width and the height, for instance. So I think, let's see, what do we want to do here? Well, we'll want to set the actual dimensions here. Let me revisit that in a moment. I just want to quickly scan through this code and see what else with the collider code. Let's see, we've got a collider here that we're adding, and that's just pushing back to our collection. Another collider here, so that should be okay. Okay, so let me see if this actually runs. Can fix some compilation bugs here just for a few moments. And we'll have to, again, position the colliders every single frame. And let's see here. So in game entity at line 43, we want to check each of the colliders at an index, make sure that they're not null, just in case we add functionality later on to remove colliders, which we will eventually want to do in this little API here. Okay, so let's see, line 69 here. And let's see. Since we are returning the actual collider, I will dereference it here. Now, eventually, I might want to refactor this and use smart pointers and some of these things. That would also be okay and perhaps ideal, but you know, we'll get to that in a future lesson. Let's just see if we can get this working here. So I've got our objects here. You can notice that they're not colliding because our there's in the very top left corner, you probably won't see it unless you've got a very big monitor. There is a tiny pixel there with our defaults. So now our options basically are to use our somewhat clunky API, and maybe we'll revisit this to update the collider dimensions here. So let me go ahead and I'll leave my main up here. Let's go ahead and open up the colliders here, and we're going to see that we're going to have to set the absolute position and set the dimension, and every frame essentially get the textured rectangle component here. Okay, so let's go ahead and do that. Now there is a method to this madness. Eventually we're going to want to pass around a transform component, which will clean things up a little bit, but for this video here, let's just go ahead and manually sort of set the dimensions for each of our colliders. Again, just to see if we can get two working, and then we'll have to think a little bit more yet about how to handle the collisions in an intelligent way. So more to come, folks. So anyway, let's go ahead and do object one. Let's get the collider here, 2D. And then we want to set the position 2, well, whatever object 1's set, let's see, get position x's, so at the bottom here, and then do the same thing, object 1, get position y, and there we go. And then we'll set the dimensions here. And remember, the collider that we're getting has an index, so this is going to be number 0 here. Let's go ahead and set the dimensions. And again, this is a little bit helpful. Again, you can see having a relatively uniform API, meaning with how I've just named things, so width, height, position x, etc., makes things a lot easier. Get height. Make sure we match our parentheses here and indent things appropriately. Okay, so let's go ahead and just do a quick build and see if we've got one of these working, and then we'll go ahead and add another one here. Of course, we've got to get the textured rectangle. That's why this is a little bit clunky here. There we are. Get the textured rectangle, and this returns the position. There we are. There we are. Okay. Get textured rectangle. Not too bad with some IntelliSense, but you can see that there are 3 levels of indirection here. So again, we want to probably get rid of some of that later on here. Let's go ahead and see if that did the trick. And just a missing parentheses here. And now let's go ahead and give this a try and rebuild here. And again, get collider is returning the actual component here. So we don't have to use the pointer here. So let me go ahead and just fix that up. Sometimes I lose a little bit of track here, but this is how the development's done. And speaking of me thinking about the uniform APIs, this is actually set absolute position, again, because we don't have any sort of mechanism otherwise for relative versus absolute positions for our colliders, which again might be useful perhaps once we have a transform component. So if I go ahead and run this once, we can see our Kong here, and it's all set here. Okay. Let's go ahead and do this for our second object, make sure that it's working, and then we'll write a little bit of collision code just to make things work. Now, since I've got this up and running, I'll get everything up on one screen for you, just so you can see here. And essentially, we've just got to make these objects 2 here, just to increment here. And again, we'll want to clean this up a little bit, but slow and steady here. So let's go ahead and do another build. And just give that a moment. And we'll give this another run. And the moment of truth, do we detect collision? We do. So now what we want to do is let's go ahead and add a second collider component to our object 1 here. And essentially what I want to do is just have perhaps just tighten up these dimensions here to maybe the top half and the bottom half of the Kong. And then we'll go ahead and call it a day here, because I think you'll get the idea of the video here. So for object 1, I'm going to add a second collider. And let's go ahead and modify the dimensions here of our colliders. So this is going to be now index 1 for the first object. The positions, I'm going to make the same. I'm just going to make the, well, let's go ahead and modify things here just a little bit interestingly. Let's make the height here half for each of them. So we'll divide by 2. And the Y position here for our second collider here, I'm going to add object 1's position, essentially. So I'll get the textured rectangle, get the position Y, get position Y. And I will add that to our position here. So and just half of that position. So let's go ahead and let's just see if that renders. I don't care if it collides yet. I'll add that in a moment. Okay, it looks like I have this object here. Now, it's a little bit wonky here because as I'm moving around, but we can actually see there's two colliders here. So it's not colliding with the bottom one yet because we don't have a check to do that. But let's actually do that. And actually, let me actually get this done properly here, and not use the position Y, but the height here. So the height divided by 2. Let me actually make sure I did that properly here. So I'll set the dimensions half as much, and then this one I am adding, well, whatever the current position is, and then half the additional height here. Okay, so that seems reasonable. Now let's actually detect the collision here, and that's just happening in our handle events. And we have our colliders. So is colliding with hitbox 1. And let's go ahead and do the next check here. So object 2, and I'm checking against object 1 that has the 2 different hitboxes. Let me scroll back down here. And then is colliding with hitbox 2 here. So maybe I'll come back and refactor this a little bit just to make things a little bit more clear, but I think you get the idea here. We should have a get height here. Let's see, dot get height. All right. Let's see if that does the trick here. Again, you can see some of the importance here of having the build scripts and these types of things just to get consistent builds and rapidly iterate in a sense. Okay, so now we've got our Kong here with 2 different hitboxes, and we can see it is colliding with hitbox 2. And let's see, double collision here with both of these hitboxes and just with one of them if I just click the top box. In fact, one more thing, because I'm a bit of a perfectionist here, not colliding with hitbox 1. Just so you can see everything that's going on with hitbox 2 here. And then we will call it a day after this one. I think this will just make it a little bit more clear on the actual output here. And there we are here with the collision. And again, other things that I might want to improve here, shrinking the hitboxes or automatically bounding them. You could really start to do a lot with this system here. But it is nice that you have the little debugging here. We have the moving object, which makes it kind of nice to test against. Here I'm clicking, you can see it's against both, or just the top hitbox here, or the second one. Okay. Alrighty, folks. So this was a big one here, and we tackled collision, we tackled color keying, we did some refactoring of our code, we saw how we could have multiple colliders, and again, we're thinking about how we can tighten up this API for this little game framework we can develop with SDL2 here. So I hope this has been useful. I know this is a longer video, but I hope the code's sort of interesting. I've actually will include this code as part of lesson 24 and 25 if you've been following along with the code samples in GitHub repository. But anyway, I hope this was useful and you enjoyed it. If you did, like and subscribe. And if you prefer these longer videos where we do more code like this from scratch, let me know. If you'd like shorter videos and want to figure it out yourself, also let me know in the comments. I'm happy to try either. So thank you again for spending your time with me. We'll see you in the next one.